Welcome to Endless Learning Training Series, the membrane-based desalination technology.
In this presentation we will study about dry bulb temperature versus wet bulb temperature. Why do we need dry and wet temperature measurements? How wet and dry bulb temperatures affect comfort. Importance of dry and wet temperature in instrument air systems. Dry bulb temperature, the actual air temperature, measured with no consideration of moisture content, typically measured with a standard thermometer or temperature sensor. Wet bulb temperature, temperature of air that accounts for its moisture content, often measured with a wet bulb thermometer. Wet bulb temperature is affected by the evaporation of water, which cools the thermometer. It can be calculated using the psychrometric equation, where Y, dry bulb temperature, wet bulb temperature, Y, actual partial pressure of water vapor in the air, saturation pressure at the wet bulb temperature, wet temperature equals air temperature humidity. Rate of evaporation depends on the moisture content of the air. If the air is dry, more evaporation occurs, leading to a greater cooling effect and a lower wet bulb temperature. If the air is saturated, i.e., the relative humidity is high, less evaporation occurs, and the wet bulb temperature will be closer to the dry bulb temperature. When are the wet and dry bulb temperatures equal? The wet and dry bulb temperatures are equal when the air is fully saturated, meaning the relative humidity is 100%. At this point, no evaporation can occur because the air cannot hold any more moisture. This condition typically happens when the air is very humid or the temperature is at its dew point. Human comfort and heat stress, cool and dry air, low wet bulb, low dry bulb. This is generally comfortable, as evaporation of sweat can occur easily, cooling the body effectively. People tend to feel cooler even if the temperature is slightly high. Hot and dry air, high dry bulb, low wet bulb. The air feels hot, but sweat can evaporate easily, so the body can still cool itself efficiently. This can still be tolerable as long as the dry bulb temperature is not extremely high. Hot and humid air, high dry bulb, high wet bulb. This is uncomfortable because sweat cannot evaporate easily in high humidity, causing the body to feel much hotter. In extreme cases, wet bulb temperatures above 35 degrees Celsius, the body can no longer cool itself, leading to heat exhaustion or heat stroke. Role of dry and wet temperature in instrument air systems. Dry temperature. High dry temperatures during compression increase the air's energy requirements because the work needed to compress the air rises with temperature. If the air gets too hot, the compressor's internal parts, like piston rings, cylinders, or screws, may overheat, leading to premature wear and tear. Wet temperature. Wet temperature affects how much water vapor the air can hold. The higher the temperature, the more moisture remains in the air. During the compression process, as air cools down, water vapor condenses into liquid water. Without proper drying, this moisture can corrode equipment and contaminate the system. Summary of effects on an air compressor system. High dry bulb and wet bulb temperatures, increased energy consumption, higher risk of moisture-related damage, corrosion, contamination, reduced system efficiency. Low dry bulb and wet bulb temperatures, more efficient operation, denser, drier air, lower risk of moisture damage. Potential issues with low temperatures causing ice or freezing in extreme conditions.
Thank you for watching this video.